All right, so Harbaugh. What's my recordings by doing? All right, we got a triangle here. Now, to know everything we can about this triangle and about the sides that create it, I want to figure out a couple different things. And these are three things that you're going to need to be able to figure out. And if I kind of move up here, I'll use a different color. Something that contrasts all the darkness here. One, you need to be able to calculate the slope of each side. Second thing is you need to be able to calculate the length of each side, which is the distance formula. And then three, what I want you to be able to do is to write the equation of a line containing each side. And these three things are going to be what we use for every shape that we're going to be dealing with. Now, if we start approaching this as one side at a time, things are going to be a whole lot easier for us. So, we're going to be calculating slope, length, and then the equation of the line. And the big example that's going to be given to you, that once you have it once, all you have to do is, there are three sides to it, so you're going to have to do these three steps 3 different times. And you're saying to yourself, oh my God, I have to do this 3 times? Yeah, you kind of have to do. I'm going to look at side AB. And go from there. Now, the first thing I have to do is calculate slope. What are the coordinates of A? 5, 10, correct? And the coordinates of B? 11, 16. Now, first off, slope. What's the equation for slope? That's the point slope equation. y2 minus y1 over x2 minus x1. I'm going to show you a different way than this. I'm going to show you actually 3 different ways to do this. So if we just take the points, and if you just have points from here, you can kind of think of this as x1, y1, and x2, y2. Could I flip them around and use this as x1, y1, x2, y2? Yeah, it doesn't matter as long as you're consistent. So I'm going to take y2 minus y1, which would be 16 minus 10. And then I'm going to take 11 minus 5. What's 16 minus 10? 6. What's 11 minus 5? 6. So what's 6 divided by 6? 1. Just so happens in this case I got a slope of 1. Is it always going to end up being a slope of 1? No. In this case, it just did. And you can kind of tell that it is a slope of 1 because you see how it's just cutting through diagonally through each box? It's hitting from one endpoint to the other, or one vertex to the other vertex of each square here. If it does that, then you can almost tell that it's 1. So that's one way to do it. Another way to do it, I like this way. I create a little table of values here. And I put a point. I just take 1 point, 5, 10. And then I put the other point, 11, 16. Now for slope, do we add the points or do we add the y's or subtract them? You subtract them. So if I subtract them, what's 5 minus 11? Negative 6. And this is my change in x, my delta x. Have you seen delta x before? Anybody see the delta before? Okay. If you haven't, this means change of. And it is the Greek letter delta. It's not a triangle in this case. I know, too many symbols in math. It makes everything kind of crazy. Now, what's 10 minus 16? Negative 6. This guy is delta y, which is the change in y. And from here, the slope is going to be equal to delta y divided by delta x, which is negative 6 over negative 6, which is 1, positive 1. Negative divided by negative is positive. Is that the same thing we got before? Muy bien. Now, another way to calculate slope is to, and I'll use a highlighter in this case, is to just, on the actual graph itself, is to draw your horizontal and vertical components. Like this. Now, I always draw them in vector form, which means that they look like rays, but they just kind of they show you how the length of them are important in this case. It doesn't go on really forever. It's just telling you, this is just telling you, the arrow is telling you which direction they're going, and we need to calculate the size. The nice thing is all we have to do is count. 1, 2, 3, 4, 5, 6. This is 6. It's going up. So is up positive or negative? It's positive because it's moving up. Now this is moving right. So is right positive or negative? That's positive. Count it up. 1, 2, 3, 4, 5, 6. So we have 6. So I can figure out my slope is going to be my y, which is positive 6, over my x, which is positive 6, which is 1. So basically there's 3 different ways. There's that way, which got you this answer. This way, which is absolutely the exact same way, it's just organizing the information a little bit different. And then this way, if you have the picture in the graph, you count your way over to from one point to the next. If we went from B to A, it would have been 6 in the negative direction and then 6 down, which would have been negative 6 over negative 6, or negative 6 over negative 6. Still would have got a 1 as your answer. So it doesn't matter which direction you go. like if I went from C to A or from A to C, I'd still get, now this line right here, would it be positive or negative? It'd be negative. Now, the cool thing about this is once you figure out slope, you can figure out the length really easy. So 2 for length, your distance formula is your change in x squared plus your change in y squared, the square root of that. So what did I get for my change in x? What was the difference between x2 and x1? 6. And if I square that, and then I look over here, what's the change in y? 6. We'll square that. So what's 6 squared? That's 36 plus 36, which is the square root of 72. Now, even better yet, if you wanted to simplify this, because if you look at the square root of 72, you're thinking to yourself, I'm not quite sure what it is. It's not quite 8. 8 is 64. One's away. It's not quite 64, which would be 8 squared. It's not quite 81, which would be 9 squared. So you're between 8 squared and 9 squared. So you could also think of this as 36 times 2. Now what's the square root of 36? So it's 6 times the square root of 2. And then you could use a calculator to figure that one out there. Now, unfortunately at this point, we're kind of out of time. But the nice thing is, the 6 you can get from here and here. The 6 and the 6. The 6 and the 6 are here and here. Or they're here and here. So you can use any of those values to do that. And tomorrow when we start up, we'll start up with part 3, which is how do we write the line? Alright. You guys need to be quiet while we're doing this because I'm going to actually finish up the video so I don't have to write 2 videos, and put your phones away or else I'm going to take them. We're in a red zone. You're in a red zone till lunch, so there should be no phones. Use the point slope equation. You don't have to write this down. You guys can pack up because you're going to leave in a second here. Equation. Y minus y1 is equal to x times x minus x1. Pick a point. I'm going to use 5, 10. So x is equal to 5, x1 is equal to 5, y1 is equal to 10. I know my slope, that's an m. Slope is equal to 1. So I get y minus, I got my 10 here, is equal to 1 times x minus 5. So I get y minus 10 is equal to x minus 5. By distributing the 1, doesn't really do anything. Add 10. Y is equal to x plus 5. Where I know my y-intercept is equal to 5. My slope is equal to 1. And in this case, I have an equation for the line that if we extended it out, would cover that, and that would include that side of the triangle. Now your job is to figure out the other two.